Hi, Jemiah. So looking over a few of your questions, starting with number one, um, you can think of this as division because it has the same root. So if you divide 6 by 2, then you get 3 on top. And x divided by x to the third, if you were to write out 3x's on the bottom, 1x on the top, 1x would cancel, and you're left with 2x's on the bottom. So if you just simplify by regular division, this is what you end up with. But remember that you can't have a square root in the denominator. So we need to rationalize that in order to get rid of that square root. So what we did is multiply by the fourth root of x squared. And so on top, you just multiply what's on the inside. On the bottom, technically that would be x squared times x squared, which is x to the fourth. So the fourth root of x to the fourth is just x. So that's how we did number one. Number two, in order to get rid of the negative exponent, we have to do the reciprocal. So we brought that down to the denominator, and now it's a positive exponent. Then I just rewrote it in radical form. So once I rewrite it in radical form, I'm then going to think about what is the third root of 243. Now, it's not an even third root, so if you were to think about making your factor tree, what you would come up with is 3 root 9. So that's where those numbers are coming from. And remember, when you have x to some power, you divide the power by the index. So 14 divided by 3 is 4, remainder 2. So now we have x to the fourth, remainder 2. So that's what's left on the denominator. Now we can't have a radical in the denominator. So if you were to think about this as 3 squared, in order to take the cube root, you need 3 of something. So you need one more 3. So that's where this 3 is coming from to multiply. Same with the x's. You only have 2. And you need 3 in order to take the cube root. So we're also going to multiply by one more x. So that's where the multiplying by the cube root of 3x is coming from. So when you multiply that, then now you have 3 3's and 3 x's. So it just becomes 3x. Okay? And then you just multiply 3x to the fourth times 3x, and you get 9x to the fifth. And that's your final answer. The next question that you asked about was 7. So that's this one right here. So what I did first was add this to both sides to make it even. And then notice how they each have a fractional exponent. So if I were to raise that exponent to another power, remember that's multiplication. So if I have to the power of 1/6 and I raise that to the 6, that becomes 6 over 6, which is just 1. So that's why I no longer have an exponent here. For this one, if I have 6 times 1/3, then I have 6 over 3, which is just 2. So that's where this is coming from. Then remember, when you have a quantity squared, you have to write it twice. So you need to FOIL. So I FOILed that here. And then we have a quadratic. So I wanted to move everything to one side. So I moved over the 3x, moved over the 4, and then this is my simplified version. From here, try to factor. So whatever factoring method that you use, I think I went over the box with you the other day, whatever works, as long as you can come up with the factors. And once you get these factors, set them equal to 0. So you have 4x minus 3 equals 0, x plus 1 equals 0. I didn't show that step, but you set each of those equal to 0 and then solve for x. And then you get these two values. Remember, that's also really important to plug these values back in to see if they're extraneous or not. The next one that you asked about was 10. So looking at 10, you start with this equation right here. Now the first thing that you need to do is take the inverse. So remember, in order to do that, you switch x and y and solve for y. So remember that this is the same thing as if you were to have a y there. So I switched x and y. So now I have x equals. And then I got this all by itself. So I added the 1, then I divided by 4, and then I have the square root of y. So to undo that, I square it. And so this is my final answer. The reason that I separated it, I just squared 4. So if you just square 4, you get 16. if you were to have this whole quantity squared, that's the same thing as well. So either answer works. That's totally fine. Then to graph, I picked values for x. I picked ones that were easy to take the square root of, plugged them into this original equation, and then got my y values. So that's the easiest way to graph. So that would be the purple function that I just graphed. And then in order to graph the inverse, all you have to do is switch the x and y's. So that's all I did here, switch the x and y's for my original table to get the green graph. Lastly, you asked for 14. So 14 says g of the inverse of g. So the first thing that you have to do is actually find the inverse of g. So remember, switch x and y, solve for y. So g in this case, I don't have it in front of me, but it was a square root function. So if you switch x and y and solve for y, you end up with x squared minus 5. And so this is saying g of the inverse of -1. So you would plug in -1 into the inverse. And once you do that, you get -4. Then you would plug that one back into the regular g. So you have two different equations here, g and the inverse of g. And then I think you might have also mentioned 16. That's the same thing. So what you want to do is just make sure you take the inverse of h. So switch x and y and solve for y. And then after that, just plug in 10. So that's what I did here. I found the inverse, and then I just plugged in 10. Please let me know if you have any further questions. I'm also available in the morning tomorrow. I'll be there at 7. So if you'd like to come early, please let me know. All right. Bye.